Okay, welcome to the first video. This is the very first one on our pre-calculus section for calculus. So, I always put an introduction slide on just to kind of do something as our intro. These are some of the words we'll learn over the course of the year. Hopefully you know some of them already, like say functions, a pretty big one, you should know that. Some of the bigger ones that you're going to learn about over the course of the year are things like derivative. That's one of the biggest things we talk about. Integral. Those are actually opposites of each other, derivative and integration. Differential is actually another word that you kind of use when you talk about derivatives. We'll talk about some people in this course, like say Leibniz. Sir Isaac Newton's also involved. Has he got a name in here? Anyways, so let's move on though. Let's get started. I don't want to waste time. Before I do though, let's talk a bit about what I'm trying to accomplish with these videos. I'm going to move fairly quickly through these, so I'm going to do my best to limit them in terms of time so that they are condensed. What I need from you guys is if you need more time for something, unlike in class where sometimes there's some wait time where a teacher will pause so you can get caught up. For these videos, you won't have that. So this is where, you have a pause button. Press the pause button on the YouTube player or rewind it, okay? Some students have actually found they've put actually the setting on sometimes to play it at 1.5 speed or double speed. It makes it sound really funny because then I think my voice goes like high pitchy and stuff like that. But it's another option is you can play with the speed of the lessons here to meet your needs. But I'm going to try to do these as condensed as possible so that you're not watching like a 2-hour video every time. Hopefully we can keep it pretty straightforward. So anyways, to get started, here's our first topic. This is a review of some skills you're going to need from grade 11 and grade 12, the pre-calculus courses you took. And they are on factoring and rationalizing as our first goal. So we're going to talk about polynomials today. You hopefully recognize that word. A polynomial usually has a format like this. You have a certain number of x, say, let's say you have 2x to the 5s, and then maybe you'll have some x to the 4s, and maybe you'll even have a negative amount. Maybe you'll have negative 3x to the 3s. And sometimes we won't even write in the next one. Maybe you have no x squareds. And so one option is you just move on to the next term and just start talking about your x's and then maybe your constant terms. Sometimes you might actually go ahead and write in that you have no x squared. So that's even possible too. So those are polynomials, and you hopefully should have some expertise in factoring these. So let's do some examples of that. Here's some things you should know how to do. Common factors, trinomials, differences of squares, and that quadratic formula. So let's do some examples. Actually, no, we're not doing some examples. Let's talk about how to do these ones as we see them on here, because I don't think we're actually doing examples of these. No, we aren't. Okay, so let's do these examples. For a common factor, you might do something like this. You might factor out a 3x, and it'll leave you with x plus 2. Hopefully that's something that you're familiar with. If you are not, make a note of it, and make sure you let me know, okay? When it comes to these videos, I would definitely recommend you can watch them again if you need to. Pause, rewind as you need to, but also make a list of things that you didn't understand. And on Tuesdays and Thursdays when we have office hour time, get a hold of me and let's talk about it. But hopefully you know how to do common factors. Hopefully you know how to do trinomials. This one will be x plus 2 and x plus 3. And the reason why that works is maybe you've learned about adding to 5 and multiplying to 6. Here's the difference of squares. These are a little unique because they are binomials, and they are always separated by a negative sign, hence the term difference of squares. And essentially what should happen is you need two things that are square rootable. If they both square root, then it can be a difference of squares. And it'll work like this, 2x, because that's what 4x squared square roots to, plus 3, and 2x minus 3, and then the 3 came because that's what happens when you square root 9. Last thing you should know is how to use that good old quadratic formula. If it's something that you're not familiar with, again, shoot me an email. We'll talk during a video conference kind of class. But I'm going to move on because I actually want to show you something new. I want to show you some formulas that are beyond regular factoring that you'd have learned in, say, grade 11. I want to show you a new type of factoring, and these are for the sum and difference of cubes. It's another formula, essentially. You need to have two numbers that are either being added or subtracted. Again, they have to be binomials. They have to be binomials. They have to be cubic, so the power has to be the power of 3. And it's kind of similar to the difference of squares formula. Basically what ends up happening is if you were to distribute and FOIL this all out however that was required, you'd discover that many of the terms would actually cancel each other, and you'd only be left with the a to the 3 and the b to the 3 either added or subtracted. So I believe now I have an example we're going to try, and then we'll test it out just to prove that it's right. So my question for you then is factor. Now, if you were in grade 11 or maybe even in grade 12 class, you probably wouldn't be asked a question like this because this would be on that expectation. But now, armed with a new knowledge of a formula, this, hopefully you can see, involves a binomial. Both of these values can be cube rooted because x cubed cube roots to x and 27 cube roots down to 3. We just need to figure out which formula to use. And so, I mean, just look back on the previous slide. It works as a plus b. Oh, wrong way. And then it is a squared minus ab plus b squared. Okay. So all we got to do is figure out who a and b is going to be. A and b are going to be these two terms here, but they're going to be the cube-rooted version of this. So a is going to need to be x in all of these examples. And b squared, well, b, since b is actually, like, since this is to the power, this is 27, if you were to cube root 27, b, hopefully you can figure out that's going to be 3. So we're going to need to do this. And 3 squared, by the way, is 9. There, we've actually factored it. And one of the nifty things about this is there is a possibility, however slight, that this guy right here could actually be factored again. This one doesn't because I don't think there's any numbers that will add to give -3 and multiply to 9, but that is a possibility. So let's prove it. Let's distribute just to prove we did it right. So, video rendered. If you ever see that pop up, it means that another video that I'm making is just finished. So let's distribute. If I do x times x, it's going to give me my x to the 3. New color. If I do this x times that minus 3x, I'll get minus 3x squared. What else will give me x squared? If I do this one by this one, it'll give me positive 3x squared. I'm doing it kind of out of order just to kind of prove how this will work. If I do x times 9, I'll get 9x. But if I do this one times that one, I'll get minus 9x. And then for our last color, if I do 3 times 3, or 3 times 9, it should give me 27. And hopefully you guys can visualize here, I'm sure you can, that, look, those middle terms will cancel each other, these middle terms will cancel each other, and lo and behold, yes, we do end up with x to the 3 and 27, based on this guy right here being, I'll just erase all this so it's not so messy anymore, based on this one here being what it factored to. So that's a nifty trick. That's something that could be useful in solving a question. So let's try another one. This one here is now a difference of cubes. So by virtue of being a difference, the formula does change a bit. It's a minus b. And then the formula was a squared plus ab plus b squared. Let's just confirm we did that right. We did. All right, so I'm going to go a little faster here. When you cube root 8x to the 3, it gives you 2x. So that'll be 2x squared, which will be 4x squared. And then I'm not going to throw in this a just yet. I'm just going to call it 2x for right now, and I'll deal with it once the b shows up here. This right here is going to be cube rooting y cubed is just y, so we'll need a y there. We'll need y squared there. And then this guy right here, we'll have to put the 2x with the y. There, something like that. Maybe do a quick check just to make sure it all looks like it should hold. 2 times 4 would give you 8 with an x squared. Another x squared is x to the 3. That looks good. This y times that y squared will give you y to the 3rd, except I made a mistake. This happens once in a while, by the way. Kids who had me teach them before know I'll make mistakes, which is okay. Hopefully we find them, and sometimes you learn more from the mistakes. This y times this y squared is not y to the 3rd. Well, it is, but it's positive y to the 3rd, because this should have been a negative. So, my bad. Now let's try it. Negative y times y squared is y to the 3rd. If I did this one times this one, it would give you a negative 4x squared y. But if you did this one and that one, it should have given you positive 4x squared y. So anyways, let's move on. If you need to rewatch that, or ask questions later. So, all right, next skill. I need you to be able to do some factoring where you have rational exponents. If you don't recall the word rational is just a fancy math word for fractions. So if you have, like, see, a to the power of 1/2 or x to the power of 9/2, that would be rational exponents. There's a fraction as your exponent. So before we get to that, though, let's do some basic review of some of the rules of exponents. Hopefully you've seen these before. If you have a squared times a to the 3, it's a to the 5. Quick proof why. A squared really means a times a. A to the 3 really means a times a times a. And if you are multiplying in between them, you really just have now a string of 5 consecutive a's. So 2 of them plus 3 of them is 5, which is strange because, yes, you are multiplying, but really you're just adding more a's to your string of multiplication. Hey, look, my notes have another mistake. Again, sometimes you learn more from the mistakes than you do from the things you're intending for. This is obviously an error here. Without me pointing it out, hopefully you can look and figure out why this next line is incorrect. Pause the video if you can't. But here's the answer. It actually should have been a to the minus 1, because a2 divided by a3 really means you have 2 of them, and then you want 3 on the bottom, and 2 of them will cancel. You'll be left with 1 over a, which hopefully you're aware is a to the minus 1. You have 1a on the bottom. Negative exponents means that they are reciprocals. So this is an error in our notes. It happens. Last one, if you actually have them in brackets and you multiply, what this really means is you have a squared, but the 3 means that you have 3 of them. So you really have 2 a's, and then 2 more a's, and then 2 more. So I should have a grand total of 6. So hopefully those are some rules that you are aware of and you've seen before. Let's use them now, though, with rationals. So rationals means we might have some exponents that are fractions. And I'm actually going to ask you to factor these. So one of the things you can do, though, is you can factor out a rational exponent. For example, there is actually something in common in all of these terms. Yes, they all have an x, but more than that, they all have x with at least a 1/2 as part of it. So I'm going to factor out x to the 1/2, and I'm going to remove a 1/2 from all of these terms. Now, if I remove 1/2 from 5/2, essentially I'm subtracting according to my rules. So 5/2 minus 1/2 means that you actually got 4/2 left over. 1/2, when you multiply it by 4/2, gives you that 5/2. Then for the next one, the 3 will have to remain. When you factor 1/2 out of 3 halves, you're essentially subtracting because you're dividing them away. You're dividing it out. Dividing means subtract. So 3 halves minus 1/2 leaves you with 2 halves. Oh, that should be 2 halves. Let's fix that. 2 halves, which sounds really strange to say, but let's talk about that in a second. And then 2x to the 1/2, if you factor out the 1/2 that's there, well, really the 1/2 comes out front. Another way of approaching it is that you really need no x's left over, right? 1/2 of an x plus no more gives you the 1/2. So, but this is a really strange way of writing things. I'm going to do a little erasing here. We would never write it as 4/2 and 2/2. 4/2 is just squared, and 3/2 or 2/2 is just to the power of 1. We don't even write that usually. Well, this actually can be factored again. You could write this as x to the 1/2, and then it'll be x plus 2, x plus 1. And this is now factored form. Now this is a big leap, hey? Like, this is a lot different than what you've done, especially if you're doing this at the same time as 30-1. If you've done 30-1 already, though, this is already a little beyond the factoring skills of 30-1. So you're going to want some practice on this. I should point out there is a textbook you can use, and I can find you questions in textbooks on this. It's the McGraw-Ryerson one. I think it's red. Hopefully schools in the division have it. But I've also got practice questions on the assignments too. Let's try another example. Again, if you need more examples, or need more help, I mean, rewind the video, watch it again. Pardon me while I cough for a second. Okay. Before we do this one here, let's talk about the one above it again. On this one here, what it is, I factored out the smallest x possible. Let me just make up another quick example here. Let's say I give you x squared plus x. You would factor it into x and then x plus 1. Hopefully you would. Hopefully that made sense to you. The reason why we did that is we factored out the largest exponent that was common. That makes sense? We found the largest exponent that was common. Each of these had an x in it, so we factored out the x to the 1. Maybe another way of looking at it, though, is we factored out the smallest exponent that we had. See how this one's x squared and this is x to the 1? The smallest one that we had was the x to the 1, so let's factor out the x to the 1. Well, if you use that logic, isn't that what we did up here on this one we did earlier? Isn't the smallest exponent we have the x to the 1/2? So let's factor out the smallest one. Well, that same logic is going to apply to the next one here. When we try to figure out what to factor before we begin, we should factor out the smallest of all of them. And the smallest exponent here on a number line, the lowest integer, is the x to the -3/2. That is the smallest number that each of these has. So it's a bit strange at first, but let's walk through it and see how this works. We need to make it so that we put some x's right here, and if we combine these two x's right here, they add to 1/2. We need to add to 1/2. So if this is x to the 3/2, and we're going to want them to be in versions of 2, right? We're going to keep them in halves. Then this number here better be 4. Watch. -3 halves plus 4 halves, -3 plus 4 would give you the 1/2 you need. Okay, well, now I need this to end up being at -1/2. So if you have -3/2, and we want this number right here to add to the -3/2 to get up to -1/2, you better make this 2, right? Because -3 plus 2 will give you -1. And then for your last term, this one's really nice always, the constant term, when you factor out the whole x to the -3/2 right here, well, then the only thing left is the 12. Most of the time, it will leave you with something like this, x squared plus 7x plus 12, right, where this reduces to a 2 and this reduces to a 1. Now, it doesn't have to be 2 and 1, but there's definitely a good shot that it will be. And then you can factor it again, x plus, let's see, 3, x plus 4. There, now we factored. So again, you can rewatch that if you need to. One more thing I want to talk about, though. We should talk a bit about what this means right here, because students are often forget how to work with negative and fractional exponents. Negative exponents mean that they are on the bottom of a fraction. So this actually means that you have 1 over x to the 3/2. That's what a negative exponent does. It puts it on the bottom. As well, the fractional exponent, if I can kind of keep going here, the bottom of the fraction actually refers to the type of rooted that this is. This has actually been square rooted. So you could call this 1 over the square root of x to the 3. So you might actually see this written a different way then. You might see this final answer being as x plus 3 over x plus 4, all divided by the square root of x cubed. That is another valid answer that you might end up seeing. The one that we wrote right here, by the way, would be sufficient for my purposes. It's not wrong, you have factored it, but you could take it a step further. If that last step lost you, if going from here to there lost you, that is something we do in grade 11, so it's been a little while perhaps. I can do a quick tutorial on that, but ask me later, right? Make a note of things you don't get, because I do want to move on. So let's do some more examples. I'm going to speed through these a lot quicker now, though. Okay, now that I've done some of them, I'm not going to walk through every little step. So first thing I'm going to do is I'm going to factor out the -5/2. If I factor out a -5/2 out of this one, it's going to leave me with an x to the 4/2. This will leave me with an x to the 2/2. That'll just be 35. -5 and 4, yep, that's my -1. -5 and 2 is my -3. -5/2 is just the number we have there. So we should be able to call this x to the -5/2. There's a minus sign hidden in there, by the way. And then this will be x, let's see, -7x plus 2. If I lose you on that, watch it again. If I still lose you, make a note of it, ask me later. Let's try the next one. What is in common here? Well, there's actually something already in brackets, and it doesn't really make sense to try to distribute because it doesn't really work that way. So the thing in common is the x plus 1, and the lowest exponent they both have is to the 1/2. When I do that, what I'm left with, I'm going to use double brackets here, is an x plus 1. Now, this x plus 1 needs to combine with this x plus 1 to make a 3/2, which means that better be a 2/2. And then we're going to minus 2. Now, this whole thing right here is going to FOIL in, if that makes sense. It's going to distribute in, but we already pulled it off of the minus 2, so you can actually just leave the 2 there. So you pulled an x plus 1 to the 1/2 out. It left a 2/2 here, and then really this guy right here just kind of got pulled off because it got just FOILed out, or what do you call that, factored out. So a final answer here, well, 2/2, that can kind of just go away, right? That's the power of 1. If all this is to the power of 1, x plus 1 minus 2, that's just x minus 1. So that's x minus 1. And then in front, maybe we could just call it the square root of x plus 1. That would be a good answer there, right? Because a 1/2 exponent means it's being square rooted. All right, last one. Similar concept. We have an x minus 5 that needs to get removed because it's in both terms. The lowest exponent I have is the minus 3/2. So the second part, you're going to be minusing 6, well, because you're basically pulling this part off of it, right? For this guy right here, we need the x minus 5. We need an exponent such that this minus 3/2 will show up back up at that minus 1/2, and that's 2/2. Which really 2/2 is just 1, so what you're left with is the x minus 5 to the minus 3/2, and then the second binomial here is x minus 5, but you're minusing 6 more, so it's x minus 11. So there's our answer. An alternate way of writing this, by the way, would have been x minus 11 over the square root of x minus 5 cubed. That would also work. Either of these should be valid. So, right off the bat, we're into day 1, and hopefully you'll see you need to have impeccable algebra skills to go on in this course. You need to know how to work with your fractions, and you need to know how to factor without thinking about it. You need to be able to factor like I just snapped. So hopefully those are things that we can work on. Let's move on. Difference of squares. You guys have hopefully learned at some point how to factor this difference of squares. I may actually ask you to factor a difference of squares where it doesn't seem like it can be square rooted, like say 10. Well, you can still do this. If x squared minus 9 is plus 3 and minus 3, x squared minus 10 is just plus root 10 and minus root 10. Right? Doesn't 9 square root to give you the 3? Well, then when you square root 10, those are just the actual numbers you put there. So that's another thing I might ask you to do. So, for example, this could be x plus root 5. This could be x minus root 5. For this one here, I'm going to factor first, though. You can take an 8 out of both of them. It leaves you with, let's see, 3x. Yep, 3x squared minus 1. And, I mean, you can still work with this. This will give you 8 as the common term, and then you'll have root 3. Close, and don't make the x be under the square root sign. X plus 1. And root 3 as a number, like 1.7 or whatever it is repeating, x minus 1. That's another way of doing it. Okay, here's a theorem that some of you have learned if you've taken 30-1 already. It's called the integral zero theorem or the factor theorem. If you haven't done 30-1 yet, I need to give you a tutorial if possible. I know a couple of you that are doing this, so we need to chat right away, and I need to show you in more detail how this works. If you have seen this before, that's awesome. I'm not going to talk through this all this much. You can just read the words here. I'm going to show you how to factor one of these guys. So you may need to factor something that goes well past the power of being squared or cubed. We're going to make something go to the power of 4. Hopefully you've learned either long or synthetic division. I like synthetic division best. So the way you factor one of these guys is you focus on the constant term. If this thing is factorable, the only things that could factor into it are versions of 1 2, 4, 8, or 16, because those are the only things that multiply to give 16. Chances are it's going to be like a 1, a couple of 2s, and a 4, whatever multiplies to give 16. But when we're done, I'm kind of expecting to have 4 of these factors here. We'll see. So in doing that, the way this integral value works is that we're going to start testing some numbers here. You're literally going to plug in 1 into this. And to do that, to save some time, I'm going to throw up my graphing calculator. Now, I should point out, actually, this is the first time to talk about this. Although I have a graphing calculator on my screen, I am not going to use it for graphing calculator purposes. You should never going forward, you're not going to like this. You should never try graphing something and type it in and get a graph anymore. In university, and I think this is still the case, you're not going to be allowed a graphing calculator. It really defeats the purpose of what they're trying to go with. So if a graphing calculator is all you own, use it. But you may want to invest in a cheap little, scientific one. So here's what I'm going to do. I'm going to start trying some numbers. I'm going to try the number 1 to the power of 4 minus 1 to the power of 3 minus 12, 1 squared plus 28, 1 minus 16. Quick version of this is 1 is a possible factor of 16. I am going to try and see whether it equals 0. If it equals 0, this means that x minus 1 is one of the factors. If 1 is a root, x minus 1 is a factor. That's the long and short of it. Hopefully you know that vocabulary. Again, calculus is going to move a little faster, so if that didn't make sense to you, we need to chat, because that is a review of something you've learned in the past, at least you should have. So let me know, though, and I'll give you a tutorial. But in synthetic division, I like to write it like this. Different teachers write them different ways. Let's see how does synthetic division work. I'm going to write a 1, a negative 1, a negative 12, a 28, and a minus 16. Essentially, I'm writing out all the coefficients. The way it works is that you drop down the 1 and go minus 1 times 1 is minus 1. Then you'll subtract. Minus 1 subtract minus 1 should give you 0. Negative 1 times 0 will give you 0. Minus 12 subtract 0 gives you minus 12. Minus 1 times minus 12 gives you 12. When you subtract these values, 28 minus 12 will give you 16. Minus 1 times 16 gives you minus 16, which is good, because when you subtract these, it gives you 0. As you've hopefully learned from 30-1, this is now your remainder, and working backwards, this will tell you what the next portion is left. We now know that that entire thing is equal to x minus 1, and then the rest is x to the 3 minus 12x plus 16. And we've now factored off one little chunk, and now we need to try to find another factor. So with this bit again, I'm actually still looking for things that are the factors of 16, which is 1, 2, 4, 8, and 16. So why don't I try another 1 again, I guess. But it's a little different now. Now we're trying it. Let's see, keep it mostly on the screen here. I'm going to go with 1 to the power of 3 minus 12 with a 1 plus 16. And I can see that that did not equal 0, so 1 is no longer a factor. So let's try another one. Let's try 2. Oops, should actually try 2. Hopefully you guys can see this on my screen here. Let's drag it over a little bit more just because it looks like it's right at the edges. If I try 2, 2 equals 0. Perfect. So if 2 equals 0, then x minus 2 is a factor. So I now know that this thing actually is going to be x minus 1, and another factor is x minus 2. The question is, well, what is the leftover bit? So let's do synthetic division again. So I read it like this. X minus 2, kind of like this. The coefficients are 1, x to the 3. I have to put in a 0 because there are no x squareds. Then minus 12 for the x's and 16 for the constant term. Again, if this is not something you're familiar with, get a hold of me. Sorry, that's a 1. Because this ideally should be reviewed from 30-1. So I bring down the 1. Minus 2 times 1 is minus 2. Subtract makes it 2. Multiply gives it minus 4. Subtracting. Oh, did I make a mistake? Pull down the 1. Minus 2 times 1 is minus 2. Subtract. 0. Subtract minus 2. Yeah, it's 2. Minus 2 to the minus 4. Minus 12 minus minus 4. When you subtract a negative, you're adding. This should be minus 8. Oh, no, I did do it right. There we go. Minus 2 times minus 8 gives me 16. Subtract them gives you 0. I had to kind of talk myself out loud on that one. Okay, working backwards. This is a remainder. This is a constant term. There's an x. There's your x squared. It means that the remaining bit is x squared plus 2x minus 8. And hopefully that screams to you that you can make it x plus 4 and x minus 2. So our final answer in factored form is this. It appears that there are 4 factors, although the x minus 2 factors in there twice. So if you were asked for roots, there'd be a root at 1, 2, and negative 4. So, okay, rewatch that if you need to. Ask me questions about it. Put it on your list. It would not be uncommon in a course like this for you to have a list where you'd have to say, okay, I need help on this one. And that's what Tuesdays and Thursdays are for. Okay, next concept. You also hopefully learned how to rationalize things at some point. This is a concept back in grade 11. We don't do it a lot in grade 12. Long story short is that ancient mathematicians knew how to do this. Root 3 over 2, they could handle that. But they couldn't handle 2 over root 3. One was considered acceptable, the other one was not considered acceptable. And so they had a method called rationalizing where you no longer had roots on the bottom. You would do something like this. You times by root 3 over root 3 and make it 2 root 3 over 3. And that way you'd bring a root to the top but not have it on the bottom anymore. So let's try an example. This one here involves doing something called multiplying by a conjugate. It's been a while since some of you have done this, so quick tutorial. A conjugate is where you have a binomial on the bottom, and what you're going to do is you're going to multiply by root x plus 2 over root x plus 2. You're multiplying by the opposite sign of what your binomial was. It creates in a way a difference of squares, because when you distribute the bottom, root x times root x will give you literally just x. When you distribute the minus 2 by the root x, it'll give you minus 2 root x. But later you'll do root x times 2 and it'll give you plus root 2 root x. And then your last term will be a 4. And this should always work out properly, but those middle terms should cancel, which is beautiful. It ends up making it so that you no longer have a radical on the bottom. Radicals are square roots, by the way. Rationals, fractions, radicals, square roots. On the top you have to FOIL still. It's going to give you 2x to the 3 over 2 plus 4x. I should talk a little bit about how I pulled that off. This really is, this is x to the 1, right? This guy right here, though, this square root, the square root of x, if you recall, can be written as x to the 1/2. So what we actually have here is 1 plus another half. 1 1/2 is 3 over 2. So this would probably be the best way of writing it, x to the 3 over 2. And then 2 times 2 with an x is 4x. So this would be considered the rationalized version of what we started with. Rationalizing the numerator is often not mathematically necessary to simplify. Simplified form means there's no square roots on the bottom. But rationalizing numerators can actually be helpful in solving limit questions, which we'll get to in our second grouping of notes. So I do want you guys to know the skill of rationalizing. So in this example here, let's times by root x plus 2 over root x plus 2. Let's take the square root off the top, put it on the bottom. So if we do this properly, the top should become x minus 4. So when you times those together, you'll just get x. When you times those together, you get minus 4, and it's a difference of squares. The middle terms will cancel. On the bottom, it's a little more challenging. X times root x is going to give you x to the 3 over 2. Minus 4 times root x is going to give you minus 4x to the 1/2. Those are the tricky ones. Those are where I'm going to multiply by this guy, and just remember it's a 1/2 is what happens when you have a square root. X will times by 2 to give you 2x. And 4 will times by 2 for the negative 8. This is now rationalizing the numerator. There's actually square roots on the bottom. If you wanted to, you could also write it as the square root of x cubed minus 4 square root x plus 2x minus 8. You can still do that if you like, but this method up here is also valid. All right, speeding up here, let's rationalize the numerator, but this time we're going to do something a little different. We're going to factor the denominator. And this is a nifty little trick here, because you might look at the bottom and say, hang on, you can't factor that. That's actually not true. It is a difference of squares. Only it's the strangest difference of squares you've ever seen. X minus 4 as a difference of squares can be written as root x plus 2 and root x minus 2. 4 is really 2 by 2, and x is really root x by root x. So what you could do, erase this, is you could write this as root x minus 2 over root x minus 2 and root x plus 2. By the way, this was the exact same question we just did. And in one case, rationalizing is something you could do. But in this case, this is really clever. Look at this. These will cancel. The reduced answer could actually work like this. That's even better. So there's another nifty little trick you need to know. In a way, math and calculus is really a bunch of little tricks where there's really nothing necessary about it for solving the problem, but it's little clever things where you get to show off, oh, I caught that. This is a good example of that, where you're able to find the trick to solve the problem. I would say most of the time, if you are stuck on a problem and you think you have it, if you're not sure you have it, you probably don't, because you'll know. You'll have that aha moment, that light bulb moment of, I see what you did there, I caught that, and you'll know whether you're right or not in a lot of circumstances. If you're kind of flailing away and you're like, I don't know if that was right or not, you're probably not, because it should be usually in questions like this one. This is a good example of something like this, where there's a point that's trying to be made. The point is that you're going to find that these two things cancel here by doing something clever, and you'll be aware of it. So, okay, let's try rationalizing the numerator here. If we do this, before I get to that point though, I'm going to point out that yes, we can multiply by root x plus 5 plus 3 over root x plus 5 plus 3. That's obviously the part I'm going to deal with. But I also should point out that x squared minus 16 on the bottom is actually a difference of squares in its own right. So what I'm going to do is the trick, the being clever portion to this one, is I'm just going to leave the denominator just like this. I'm not going to FOIL them into each other yet because that's going to make a mess out of things. I'm just going to leave them all individually and see where it takes me, because hopefully you'll discover the trick to it. If you do root x times root x, like this root x plus 5 and that root x plus 5 will literally give you x plus 5. And then minus 3 and plus 3 gives you minus 9. But if you want to save a step here, plus 5 minus 9, minus 4. And like I pointed out just in my last kind of little talking section here, a lot of calculus is really just to kind of prove how smart you are. It's not because this is necessarily purposeful yet. It will be purposeful, I promise you. Calculus is needed for engineering and for the sciences. It gets used in economics even. But the point of what you're doing right now is to try to show off how clever you are at solving these little games. And hopefully you can see there's a little game right here where that cancels, which is just, I like the word clever. You get a lot of clever things. So you could leave your final answer like this. This would be valid. You could distribute it if you want, but I don't see much value in distributing it because distributing won't cause anything to cancel. So you may as well leave it here. The whole point, though, is can you catch how that canceled? So, okay, we're getting close to the end, right? We got a couple more examples, 2 more examples. So for this one here, I didn't actually tell you what to do. We're just trying to simplify. And that's our whole goal, is just to see where it takes us. And sometimes that's challenging because we don't really have anything to go off. We just have to say, well, we've learned some little tricks in class. Let's try it. Let's see where it takes us. So based on this one here, maybe the best option we have is let's just try rationalizing and see whether something clever happens. So let's multiply this by this trinomial, but we use the conjugate. See where it takes us. On the bottom of this crazy thing, you're going to have x plus 3, and then we're going to have this very odd-looking binomial of x squared plus 4x minus 9 minus 2 root x. But on the top, you should end up with x squared plus 4x minus 9 when these two guys multiply by each other. And then when these guys multiply by each other, 2 times 2 will give you minus 4, and then root x times root x will give you 4x. On questions like this, you need to search for that aha, light bulb, clever, what are you trying to get from me kind of moment. And hopefully you'll see here that this 4x and that minus 4x will cancel, leaving you with x squared minus 9. Well, x squared minus 9 is really x plus, oh goodness, x plus 3 over x minus 3, all over x plus 3, and I'm just going to write that stuff just to save time because I don't want to write it again. Hopefully you'll get to what I'm getting for here. Like my brain is working faster than I can write, and hopefully you're in the same spot here where you go, that x plus 3 is going to cancel, right? So hopefully you are at the same spot as me there, and you can see it, and you can go, I get what you're trying to do here. So our final answer is x minus 3 on the top, and then that stuff that I just wrote there is this. And I don't see anything more that we can do. We can write this with a 1/2 exponent, but that's about as good as it's got. Cool. Okay, again, if you need to rewatch videos as need be, make lists of questions to ask me on either Tuesdays or Thursdays. The way I envision the course going, Monday you watch video, Tuesday you ask me questions about said video and do the assignment. Wednesday you watch new video. Thursday you ask me questions about said video and do the assignment. Fridays are kind of tricky. Fridays, all schools seem to have different timetables on Fridays, so just use your Friday time as you see fit. The idea behind the Tuesday-Thursday thing, by the way, is that most weeks, if you have like a PD day on a Friday or we have a Monday for whatever reason off, Tuesdays and Thursdays are almost always days that we have. So even if you need to watch a video at home or something like that, you can watch videos whenever, but Tuesday through Thursdays can be office hours because we should normally have class then. So, oh yeah, last one. We threw more fractions in, right? So, have to find a way to deal with this. There's lots of different options. One option would be for the top, at least for the numerator, let's give them common denominators. So what we could do is we could make this root x over root x, just so they have common denominators, and turn this thing into 1 plus 3 root x over root x. And then I will divide it by 5 over 6 root x. That's a root, by the way, not a 5. If that made sense to you using common denominators, which again, I can't reteach you all of junior high and high school math again. So hopefully you get how common denominators worked right there. If you don't, then, let me know. I'll try to help you out here. But that is, there is going to be an expectation, especially when you get to university, that some of these basic skills you have. But let me know if that step right there lost you. Because something clever happens right here. And if you understand how fractions work, you'll know that those cancel. If you want a better proof for as to how it works, I might work with the concept of multiplying by a reciprocal. Rather than dividing, which these things essentially are being asked to divide, rather than having a divide sign between it, you can make it a multiply, but you have to flip the fraction on the bottom upside down. It's called multiply by a reciprocal. And if you know your rules for canceling, then this x and this x can cancel. And so our final answer will be this, 6 plus 18 root x over 5. Because I'm going to times the 6 into both of these guys there. You could leave it as 6 bracket 1 plus 3 root x over 5. That'll also work. Both would be valid. So, Okay, there's our first lesson. Boy, it's a lot, hey? Like I said, I'm not going to be pausing a ton during videos. I just kind of teach it as it comes. So make sure that, whatever day you watch this, if this is Wednesday or Friday or Monday or whatever it happens to be, make sure that you make a list of questions of things you didn't get. Rewind, pause, watch again. That's the beauty of this, is that you can watch it as much as you need. And do not hesitate to ask me questions. That's what the office hours of Tuesday, Thursday are for. They are for you to ask me questions. So make sure you do. Okay? Email me. Start looking at your assignment. I guess while I am chatting with you here real quick, I'm just going to pull the assignment up on the website. Hopefully you can kind of see this a little bit. I know the screen size is out. There we go. Class website. FP Walsh. Hopefully that's still on your viewing screen here. We need to go to, when you do it this way, it really screws it up. Give me a sec. We need to go to Math 31 Pre-Calculus. So if you haven't done this already, print off the calculus assignment. See that I can make it small enough that you can see it in your screen now. Come here. The assignment should look something like this. The way my assignments are designed to work is they should be more or less sequential. Hopefully that's the plan. And work on them a little at a time. If you, and this is a good rule in general, if you're the kind of kid who just tries to do the assignment the day beforehand, it won't fly going forward. Well, at some point you'll hit a wall and it won't happen anymore. So the advice I'd give you while you're in high school, and this is why I try to structure my calculus course similar to university. While you're in high school, build good habits so that when you get to university, you have good work habits already built. So don't try to do an assignment the day before it's due. Do it a little at a time, a little every day. If you could do question 1 and 2 today, that'd be awesome, right? The video so far looks like it's taken about 46 minutes. Depending on your class time, you might have half an hour left. If you paused the video or got a late start, maybe you don't have a lot of time left, but I bet you can do the first, second, and third questions because we've already kind of done questions like it. Questions 2 and 3 are also something kind of familiar, so maybe tomorrow or the next day work on those. And then in our next video, I'll show you how to do things like questions 4 and 5 and stuff like that. So anyways, there's my advice. Do it a little at a time. Your assignments, though, do have a firm due date. I need them uploaded into the Google Drive folder every Friday of when they're due by 3:30. I'll give you till 3:30 in case you have a different end of day that we do. And I will be able to tell you when you uploaded them because there'll be a timestamp on it. So you need to have it scanned, finished, and uploaded by 3:30. Otherwise, it's late. And we'll talk about penalties in case it's late. But a typical sort of thing if you get to post-secondary is kind of a tough luck kind of thing there. The due dates are there for a reason, and you have time. It's not like you don't have time for this. So start on it now, okay? Okay, I will end the video. Email me and get me some questions as you have them. We'll talk to you later.